Welcome back. So like I said, we're going to look at these next 6 problems on this guided notes video. So we're still on page 3 of your workbook, but now I'm looking at 5 square root 10. So we still have multiplication with that coefficient, and I'm still going to ask myself what multiplies to be 10. Well, I know 2 times 5 is 10, and that can't be broken down any further. That is also prime, so I'm going to rewrite it. There's still the 5 outside the radical, and inside the radical we just found a 2 and a 5. Now pairs make perfect squares. I'm looking inside the radical and there are no pairs in there, meaning nothing can come out. I don't have any perfect squares, which means if I was looking at this problem, it's kind of like I'm skipping this step, or maybe it's more skipping this step and just multiplying things back together. There's nothing else to do here except for put it back together. So there's still a 5 out front, there's still a square root, and now we have 10 inside the radical, which is the same thing we started with. There are some radicals you're going to be given that are already simplified, and that's okay, they exist. So don't think that everyone has to simplify. Number 8, 3 square root 25. So I'm multiplying by that 3. I'm going to break apart the 25. 25 is made up of a 5 times a 5, and those are both prime. They can't be broken apart any further. So when I rewrite this, I will have a 3 out front. I'm multiplying, and in the radical, I'm going to put my 5 and my 5. So now I'm looking for pairs. Pairs make perfect squares. Well, there's a pair right here. So not only is there this 3 outside the radical, pairs make perfect squares. The square root of 25, the square root of 5 times 5, is just regular 5. So inside the radical is anything that was left over, which is nothing. Which means this problem simplifies to a whole number and not a number with a radical. So don't think if I start with the square root, I have to end with a square root. Sometimes it simplifies completely. And I also want to point out, if you had noticed at the beginning of this problem that you know the square root of 25, you absolutely can jump straight to this step. You don't have to do this work. A lot of teachers are not going to be doing that work. But I want to show you that this process of finding perfect squares works for every problem, even ones that already are perfect squares. Number 9 is negative 6 square root 96. So I've got multiplication again. And then when I look at 96, especially after taking 5 months off of school, I don't remember anything that divides into 96, but I do know it's an even number. So I'm going to take a 2 out because I know even numbers can be divided by 2. And in my calculator, if I type in 96 divided by 2, that's a 48. 2 cannot be broken down any further, but 48 for sure can. So I'm going to keep this process of looking for even numbers. I know 2 divides into 48. That leaves me with 24. So at this point, you could do 2 times 12, 6 times 4, 3 times 8. There are lots of things you can do. I'm going to keep taking out 2 since I'm in that mode right now. So 2 times 12. 12 is not prime. I'm going to do 2 times 6. 6 is not prime. I'm going to do 2 times 3. I like to circle these numbers so it's really obvious which ones are going inside the radical at this stage. Sometimes I cross these out so I don't get confused and put them in as well. If you've broken it apart, it's done. Outside the radical is a negative 6. Inside the radical are 1, 2, 3, 4, 5 2's. So 1, 2, 3, 4, 5. And then there was also a single 3. Pairs make perfect squares. I see a pair of 2's here, a pair of 2's here. So outside the radical, not only is there the negative 6 that was already there, but this 2 comes outside my radical. This 2 comes outside the radical. Because remember, when you have a pair, that's 4. 2 times 2 is 4. The square root of 4 is regular 2. Inside the radical is anybody who didn't pair up. The 2 times the 3. So we're going to combine those back together. Negative 6 times 2 is negative 12. Negative 12 times 2 is negative 24. So that's my new coefficient. Inside the radical is 2 times 3. Negative 24 square root 6 is then our simplified answer. I'm trying to think which of these I want to do. because it is redundant. It's the same process, and you're going to get plenty of practice on the assignment that we have to pair with this. So let's see. Let's just do one more. Let's do number 10. So coefficient, don't ignore that. You're going to kick yourself if you catch yourself missing that on an assessment because it's so easy to forget the number out front. I'm going to break up 54. It's an even number, so I'm going to take 2 out. If in my calculator I do 54 divided by 2, that leaves me with 27. Not an even number, but I know 3 divides into 27. 3 times 9. So I circled the 3 because it's prime. I'm going to break apart the 9 because it's not prime. So I'm going to rewrite my original problem. I'm going to rewrite 2 times, because that's how I started. I'm going to rewrite the square root, but 54 doesn't exist in this problem anymore. We've broken that apart into 2 times 3 times 3 times 3. And pairs make perfect squares. I see a pair of 3s. So outside the radical, we still have a 2. But now, since 3 times 3 is 9, I can go ahead and put a regular 3. The square root of 9 is regular 3. So we still have multiplication. We have 2 times 3. Inside the radical, excuse me, are any of the things in the radical that haven't paired up, which is this leftover 2 and this leftover 3. So that means when I multiply back together, 2 times 3 is 6. 2 times 3 is 6. So our simplified answer is 6 root 6. 11 and 12 are really similar, so I'm going to stop at this point and jump down to the next one, and I'm going to throw that in the next video. So when we come back, we're going to be on page 4 in your